Everyone, we'll be starting the session in a couple of minutes. Again, I wish to welcome you everyone. We'll wait for just another minute till more people join us, and then we kick off the session. For all of those that joined us now, we are all welcome. We'll be starting in a minute. We'll be starting the session in a minute. If you have any friends or colleagues that can't join by Zoom, we've sent to the chat box a couple of links, one to the official Jinko Solar Sub-Saharan Africa Facebook page, so they can watch the same session live there, and our Solar Arabic YouTube channel, where you can also watch the live broadcast from there. So feel free to copy these links, send them to your friends or colleagues, and they can watch us on social media. Okay, so good afternoon, ladies and gentlemen. Welcome to this webinar about the PV module performance reliability for the Sub-Saharan Africa region. This webinar is sponsored by Jinko Solar, the leading global energy company that is active in the solar PV, energy storage, among other applications. And we have a very special guest today from TÜV Rheinland, and we'll get into the introductions very, very soon. If you are not able to join us via Zoom, or if you have any friends or colleagues that wish to join us via another platform on social media, then they can watch us live now on the Jinko Solar Sub-Saharan Africa Facebook page. There's a live stream in there, and the link is already in the chat box. You can copy that link and send it to the others. The same live broadcast is on Solar Arabic's Facebook, YouTube, Twitter, and LinkedIn channels. They can all watch these via our channels live at the same time we have this session here on Zoom. So in order to get started, I wish just to ask you, please, to comment in the chat box if you can hear me well, or if you have any problems to hear me. For those that are watching us now on the social media channels, please write in the comments if you have any issues hearing my voice. If you write this 10 on 10, Munir, Eric, you all say that you hear me well. Thank you very much. Amjad, Nessi, great. Thank you all for confirming this. It's good. I'm glad that you can hear us well. And I just want to make a note that for those that are watching us on Zoom, please send your questions as soon as you get this question. Don't delay it till the end. Just send it, and send it in the Q&A section rather than in the chat box. It's so easy to lose the questions in the chat box. That's why, and we want to answer them all. So please send them in the Q&A section. And for those that are watching on social media, then please send these questions in the comments section wherever you are on social media. So first thing first, and I'll introduce myself. So my name is Munif, and I'm from the Solar Arabic, which is the biggest renewable energy platform dedicated for the renewable energy in the Middle East and African region. We collaborate with the renewable energy pioneers in the MEA region, and that's why I'm very pleased today to have two awesome speakers that I've hosted before and have contributed a lot from their experience and knowledge. So first of all, the first section will be covered by Mr. Titus Koich, who is a Technical Services Manager for the Sub-Saharan Africa region at Jinko Solar. Titus is an experienced electrical engineer with a demonstrated history of working in the renewable energy sector, manufacturing, and the power sector. On the second half of this session, I'm very happy to host again Mr. Jörg Althaus, who is the segment manager at TÜV Rheinland, and he's responsible for the power plant services for TÜV Rheinland. He has long-time experience in the field of solar energy, representing TÜV Rheinland in many industry associations, events, speaking at expert forums, and participating in many industry standards preparations. And my esteemed speakers today, both of them, Jörg and Titus, will talk about this shift towards high power modules and how this could affect us in the Sub-Saharan Africa region, how to ensure the reliability of these new modules with especially their new form factor through product optimization. We'll be talking about the test marks and certifications of PV modules and how important are these. And then we'll be speaking about the specific stress factors for the Sub-Saharan Africa region, talking about soiling, anti-reflective coating, among other topics. Before we jump into these very interesting topics, the discussion today will be very technical, very much needed for all the solar both the players as EPCs, developers, as well as investors and interested companies and farmers and business owners that wish to install solar on at their facilities. So for us, first of all, to also know you a little bit, we'll be running a couple of poll questions. The first poll question that you see here on your screen on Zoom, would like to get to learn from what industry you join us today. And for those that are watching us on social media, then please also write in the comments section, tell us please about your work. If you work for a developer, an EPC, for a solar installer, if you come from agricultural sector, from academia, from financing, we would like to know a little bit more about you in order to tailor a bit this content as we move forward. I see that more than half of the participants are from developers and EPCs, and there's another approximately 15% from solar installers. We have people from academia, from financing, and from OEMs that joined us on the session today. You are all welcome. And the last question that I wish to ask, just to learn more about you, our participants, we wish to know from what region you joined us. And please, if you are on social media, also write that in the comment section. Are you from Eastern Africa, Central Africa, Western Africa, Southern, Northern part? Are you from the Middle East? It's very important for us to also know from what region you join us in order to focus more throughout these discussions. I'll give you a few more seconds. I see that the majority are from Southern Africa, Northern Africa, and the Middle East, but we also have participants from both East Africa and West Africa. So basically, all of Africa and Middle East are represented. I'm very happy for that. And definitely, we've got a lot of useful topics to discuss with you that are prepared for the session today. So for that, I'll be very happy then to start and to hand over to Titus to kick off this and tell us about this shifting towards high power modules from the perspective of Jinko Solar, the perspective of one of the biggest modules manufacturers in the world. Titus, the floor is yours.
Thank you so much, Munif. Just allow me to share my screen.
Please.
So, Munif, thank you so much for the introduction and ideally, and also inviting us for this particular webinar today. And I'm hoping that you can now see my screen.
Yes, it's clear.
Okay, fine. So I think as Monif said, is that from Jinko Solar, the technical science department. And our session today will be on PV module performance and also reliability, with main focus in Sub-Saharan Africa. So to start off with, I would like to briefly, in some few seconds, give some brief introduction about Jinko Solar. So Jinko Solar is a module manufacturer. We are a module manufacturer based in Shanghai, China. That is our headquarters, but we also have operations in other parts of the world. That includes Sub-Saharan Africa, Middle East, and also some other regions. So we're the first manufacturer to lead for 4 consecutive years in terms of module shipments. And also that is having delivered more than 70 gigawatts of PV modules globally as of end of 2020. And this translates to close to 14.3% global market share. That is, we do all currently. And as a manufacturer, as mentioned, that we are PV module manufacturer. So our core business is solar PV modules. And the PV modules that we've had is that we've actually categorized them into different categories. And one of the classifications is based on the applications. And we do have PV modules that is for residential applications, commercial and industrial applications, and also utility scale applications. So this is mainly based on the size of the PV modules. And the power class range is all the way from 400 watt peak all the way to 550. That is from our standard portfolio. But we also recently launched a new version of N-type modules that's up to 610 watt peak that we're going to have another session to discuss about that. So the other thing is that ideally looking into our portfolio is that we are only focusing on high efficiency modules, that is efficiency of more than 20%. And ideally, we've also standardized the technologies into either that is monopack, multi-bus bar, and also AFCAT technology. That is our standard technology for all our PV modules. The other thing is that, yes, we do have 2 sets of modules as well. That is either P-type and also N-type. So we expect that in the next 2 years, that is beginning next year, is that N-type is going to be more of taking over from P-type. So we're more of slowly preparing the market to that. And apart from that, also from offering PV modules, we also do offer energy storage solutions. Energy storage solutions that is based on lithium iron phosphate, also for 3 applications. That is residential, commercial, industrial, and also a utility scale. So I won't dwell so much on that because you can find all this information from our website. And also, if you're interested, you can send us an email and we'll give you details on that and based on your requirements. So despite that, is that despite leading in terms of module shipment, we are not focusing only on the volume of modules that we are shipping globally. What is our main focus also is that we've had some very huge investment in research and development. The reason why we're having such a huge investment because we also want to lead in terms of quality, and our efforts have not gone. We've actually gotten so much recognition from the market in that from different awards, from TÜV Rheinland, where we got the 7th All Quality Matters Award. That is for our N-type modules because of quality, and other awards also from PVL, from the reliability scorecard, and also from RETC, that is for the PV module index, that is for 2021. And now getting back into our main topic of today, that is with regards to reliability and more of quality of the PV modules. So the talk mainly in the industry currently is about power class and maybe efficiency of the PV modules. But what we disregard in most instances is that we disregard on the reliability, and not only the reliability of the PV modules for a short-term period, but we are looking into reliability for a long-term period. That's ideally more than 20, 25 to 30 years. And ideally, the main concern to look into for reliability of PV modules is that we need to focus more into the bill of materials. That's why I would ideally give a statement that if you want reliable PV modules, the first thing you need to know is that you need to know your materials. Like Other manufacturers, we also facing several problems from market, that is depending on market forces. And I've ideally taken a chance to categorize this into three different forces. That is one, that is the material cost and also logistical cost. We're also looking into market demands and also the prices. So I will start with the last one, is that that is with regards to the module prices, that for the last few years, let's say a decade, is that the pricing of PV modules are greatly reduced. That is close to 89% reduction, 89% reduction in the prices of PV modules. Yes, in as much as we appreciate that, is that there are also demands, market demands, which includes that is performance of the PV modules. With regards to the power output of the PV modules, that most of the clients would want to, of course, have the highest power of the PV modules, let's say up to 700 watt peak. Also the efficiency, we decide to have very high efficiencies of up to 23% currently, and also degradation, the lowest degradation. And we've also found that in some of the instances is that there's also a push for technology, in that in some of the tenders is that we're also getting specifications that the minimum technologies are actually specified, like for the case of monopack technology. So that is those are some of the things that we also need to adhere as a manufacturer. And so all this, whatever I've listed, that is from power to technology, information that you can easily get from the specification sheets. That is not only from Jinko Solar, but also from other manufacturers as well. But there's one concern that is on the bill of materials. So the bill of materials is not something that you easily get, it's not an information that you easily get from the manufacturer, that is from their specification sheet, but more of you need to go an extra mile to find out, that is from the construction data forms. So the bill of materials is one of the key factors, and is actually our key concern, because we focus more on that so as to ensure on having high quality modules. And we are going to, I'm going to explain in the next few slides on why the bill of materials is very important and why it is responsible for the quality and also liability of the solar PV modules. The other thing is also the cost. We also need to optimize on the cost. Is that we've also faced challenges, that is with regards to increase in the logistical prices, and also from upstream suppliers as well, that is with regards to the bill of materials. And now I want to just give an illustration of one of the key bill of materials that is on the solar cells. And as a manufacturer, is that we actually producing our own cells, and in some instances we are also sourcing the cells that is from other cell suppliers as well. And so for the first few, let's say for the past 2 or 3 years, is that we've seen tremendous increase in the power class of the PV modules. And what's the reason for that? The main reason for that is mainly because of the increase in the cell size. That is the cell size. That is all the way from M0 to currently at M10, and also other manufacturers are doing M12. But also with the increase in the cell size, there's also high reliability risk as well, because with the increase in the size of the solar cells, this also need to also have better mechanical strength of the solar cells to avert, or rather to avert the risk of micro cracks. That is why that we've actually ventured into Africa technology, and also some other manufacturers are also considering now that kind of technology, for which we still find that it's not still very mature. That is the technology itself is not still very mature. But of course, in the next few years, there are going to be more advanced ways of carrying the cells into 3 equal halves without having any effects or other power donations inside the solar cells. And the other thing is also on the busbar technology, is that the standard technology for the longest time has been that is 5 busbar, and also 4 busbar for the longest time. But with the increase in the cell size and in the need to reduce internal losses inside the loss cells, is that we've also ventured into multi-busbar technology, that is 6 busbars plus, and currently for the PV modules that we are focusing on, that is either 9 busbar or 10 busbar. The reason why we cost focus on this is ideally to reduce on the risk of micro cracks, that is from either during installation, during handling of the PV modules, and also during on-time as well. And the other thing also is that with the increase in the power class of the PV modules, and also the size of the PV module, it's no longer the 2x1, that is the 2 meters length and also 1 meters width for the PV modules. So we are having modules that is ideally more than 2 meters, currently up to 2.4 meters by 1.2 or 1.3 meters. And with that is that we also having the increase in the size of the PV module. That is, instead of the standard 20 kgs for one PV module, we're now having up to 25 to 30 kgs of in a single PV module. So with that, this high chances of compromise mechanical strength of the frame. And other manufacturer is that what we are mainly focusing is not increasing the size of the frame that we're using, but what we are doing is that in some of the improvements we're doing is that we're actually increasing the internal thickness of the frames. That is, we've increased the thickness by more than 30 meters, and also we've added in some wavy stiffness to, of course, improve the mechanical strength. And with this also is that we've also done some reliability tests. We've also done some reliability tests. That is a mechanical loading test, and there is RC that more of certifiable, and we are going to look into that in the next few slides when we look into reliability test that we've conducted internally as a manufacturer. And that thing also is that the connector, yes, it's a small component when it comes to having the PV module, but it's also very important in that it's actually where we are having the electrical connections, that is to the external circuits. And with regards to also the increase in power, increase in the cell size, there's also an increase in also the current of that is from the PV modules. And this also needs to, of course, accommodate this increase in current by making some few changes or other modifications in the connectors. And what we've done as a manufacturer is that we've actually increased the diameters. Instead of the normal 4 to 6 millimeters, we're now having up to 8 millimeters, and also increasing that is the upper limit of the temperatures of up to now 115 amperes. And the rated current as well has also increased from the normal 30 amperes to 55 amperes as well. And not only on the electrical parameters, we're also looking into the mechanical parameters, because looking at this diagram, we can actually see the mechanical structure, the previous mechanical structure of the connectors that we're actually using, and also what our competitors have been using is that more of a separated clip, and also the positive and negative pins as well. But what's happening now is that in the new design is that all these are actually integrated, and so as to reduce any chances of failure because of axle, any other electrical current, increased currents that can lead to failures of the connectors. So you can see the modifications to be able to avoid those risks. And also, generally, on ideally looking into the last main item, that is on the junction box, and what improvements are being done, especially in the new developments for the high power modules, is that this also needs to increase on the ingress protection, that is both for the solid particles and also for liquid particles. And you can see currently is that IP67 and IP65 have been mainly standard for the longest time, but in the new developments is that we actually having that is the top ingress protection against solid particles and also against liquid particles, that is now IP68 for all the connectors. So then now when it comes to, that is briefly about looking into the key highlights of the bill of materials used for the PV modules. So the other thing that we're also looking into is with regards to the reliability test that we do internally and also externally. And before we start in that, is that I would like to just give you an highlight on what we usually do as a manufacturer to be able to control with regards to the bill of materials that we get from different suppliers. So as I said, that we either have the solar cells that is from a local production, or we can also get it outsource the solar cells from other manufacturers as well. So what we do is that one is that we focus more into that is the material selection, and also we do internal tests, and we can also partner with also other institutions like TUV and also SGS to do the inspection and testing of the materials that we procure. And some of the tests are actually as highlighted that we do for each and every components to make sure that it's of the right material and also of the correct quality that we actually design. And so the other main focus is ideally on the testing, is that, as mentioned, is that we do all the testing of that is of the materials and also the PV modules based on the IEC standards, majorly on IEC standards, and we go past that in that we also do that is double IEC test and also triple IEC test. That is we amplify the test conditions in the test chambers. That we do double IEC test and also a triple IEC test, and the pass criteria for all the tests is actually what is required is that the pass criteria is that the degradation after subjecting to any of these pilot tests, the degradation should not be more than 5%. And from our internal tests, is that what we are getting is that, let's say for the case of LETAD, which is been a huge problem for the last, from 2019 and 2020, is that most of the manufacturers are actually getting degradation up to 10%. That is with only the normal IEC test. But what from our internal results and also what we've gotten from other labs like SGS is that we're actually getting less than half of the pass criteria, that is 5%. And also same to dump it and also thermocycling as well. So I think that we also look into is the mechanical load test. And I've said that, of course, with high power modules, that is, we having bigger modules and there's high chances of mechanical compromise of the PV module and high susceptance to micro cracks. So we've also done our internal test we also do our internal test to be able to verify that these modules that we have is actually not going to be pose any problems in case of high windy conditions, especially in some parts of Sub-Saharan Africa. And these are some of the results. That is 2.76%. That is for the DML and also the Blossom test of 1.69. So, and the other thing that I also mentioned is, it's a very important thing that we also focus on is the reliability of the junction box. And as I mentioned when it started, is that with high power modules, there's an increase in the current of general increase in the current of the PV modules, that we are now having modules of up to more than 15 amperes in terms of the short circuit current. And with this also need to, of course, have a very good safety margin, especially to avoid failures of the internal components of the junction box, like the diodes. So most of the diodes currently are rated at either 25 and 30 amperes. They're actually certified and available in the industry. So comparing what we've tested is that for our PV modules, we actually using mostly 102 millimeters. Is that we are getting actually some very good safety margins because the diode rating is 13 amperes. But you can see from the of course, the calculated current requirement is actually around 22.4 amperes. So that means that we are getting safety margin of either 10 or 25%, depending on whether you're using 25 amperes or 30 amperes, compared to, of course, the next what most of our competitors are using 210. Of course, the safety margin of less than 1%, which is, of course, it's of high risk, especially for long durations of time. Then lastly, also going to, of course, give some highlights with regards to reliability of the PV modules with regards to the increase of the dimensions, that is the length and the width. So what we've done internally and also together with our peers actually doing the 182 millimeters is to do what we call frame stress test. And from what we can deduce generally from the results is that the increase in the width of the PV module actually leads to a bigger stress as compared to the increase in the length of the PV modules. That is why is that we are very sensitive with regards to increasing the width of the PV modules. And you can see from these results, there is a plot of the frame stress test stress results that is in megapixels and also the module width that is in millimeters or rather in meters. You can see clearly from this graph is that increasing the module width past a certain value will actually lead to power attenuation of actually more up to sometimes 5%, and that is something that we're trying to avert. So ideally, we find that the safety limit is to keep the power attenuation that's close to at maximum of 2%, and that's why currently that we are limiting our PV modules to less than 1.2 meters in terms of the width, and because we want to be within the safety limit as recommended. And for this test results is that we've actually partnered this. We've done this together with TUV Node based in China. So I think that's my brief introduction to today's session. So it's now my humble, I would like to hand over to the next speaker, that is Jorg.
Thank you very much, Titus, for this insightful presentation. Definitely, it raises a lot of questions about the decisions of Jinko Solar to adopt the 182 millimeter cells to wafers and to focus a lot on the bill of materials, and we'll get into that later in the Q&A section. So of all of the questions that we received in the chat box and all of the other questions, please send them in the Q&A section, so we'll make sure that we answer these questions at the end of the session. And for now, I would like to hand over to Jorg. Welcome again, Jorg. I'm very happy to have you on board.
I'm very happy to be here, and welcome to everybody also from my side. I'll try to be on time with my presentation, so I'll go right into.
Thanks.
See if that works. I don't have to introduce myself because Munif did a very good job. So I'm going to give you just a very short background about TÜV Rheinland, which is this different organization than TÜV Süd or TÜV Nord, actually competing in the market. Then I'm going into the limitations of the general type approval certification as organizations like ours provided, and give you a bit of an outlook of the trend of module sizes and large power modules that we see. And then I'm going to dive into reliability testing that Taito has touched on, with also a focus on sand and dust testing, and conclude. So TÜV Rheinland is a testing and certification organization doing also inspections, founded more than 150 years ago, basically starting with the industrialization and the risk of steam vessel explosion. The industry decided we need an organization to look over safety and quality. That's a long time ago when it was still government organized, and nowadays it's a completely free organization. With, of course, also one sector of it working on the solar and renewable energy sector. I've been with TÜV for more than 20 years now, and always in the solar department. And I'm happy to say that also I started the business in the Middle East, and also we had a presence in South Africa that was starting in the solar business almost 10 years ago now. And yeah, we have, with the solar experts, we have presences in almost all regions, of course, with a focus on the testing, which is our laboratories in India, Germany, and China nowadays, but a lot of experts in other regions to support large-scale PV power plant technical advisory. Yeah, and with that, I want to dive a little bit into the type approval testing and its limitations. So, as any product, the PV module has a bathtub curve, as we call it, which represents a bit the lifetime, where you have early mortality, as we call it, products that fail in the beginning of the lifetime, and products that have quality risks that that will show up in the end of the lifetime. Now, hopefully, you don't have the early mortality, because that's what's supposed to be excluded by type approval testing. But then, of course, depending on the quality of the product, lifetime testing is something completely different than type approval. Type approval is basically just the market entry barrier, the minimum requirement, and it should exactly eliminate design failures. It doesn't say anything about lifetime, because simulating 25-year lifetime for the world is impossible. It's always dependent on where it is, and therefore a precaution has to be taken on the quality control, not only through certification check. You have to, in particular, when engaged in large-scale projects, have to take risk mitigation measures by doing also project-level quality control. To minimize the risk, of course, you have to identify the risk and assess the risks, and that can only be done by project-specific, or in case of retailer, large-scale quality control, doing auditing, doing sample checks, and laboratory testing again. When we look at the different influencing factors that a PV module or any PV component will see in its lifetime, we have, of course, all sorts of stresses like wind, sand and dust, heat, irradiance, vegetation, or the absence of vegetation, fauna, and sometimes animals. And I was trying to say, what's specific to the Sub-Saharan Africa region. I mean, comparing to where I come from in Cologne, Germany, of course, we do have a little bit of dust, but we don't get so much sand flying around. That's one thing. And of course, you have much higher in parts of the region, of course, much higher average temperatures, and also longer full-time hours where you have higher irradiance. So you have, of course, mechanical stresses on the modules from wind and others, and you have abrasion and soiling through the sand and dust. You have thermal fatigue, which is higher than you would for moderate climate expect, and then you have higher UV degradation. In particular, for bifacial vegetation plays a big role for the albedo, which would have an influence on the O&M cost. Then mechanical stress, and I put in question mark curiosity. I found a nice picture on Shutterstock showing that animals also play a role and should be kept a close eye on. Enough with the joking. If we look at the standards for type approval and safety qualification of PV modules, namely IEC 61215 and IEC 61730, within their very scope, they say what they have been written for, and that's a little bit I have to decipher. It takes reference to a world map where it says it's for long-term operation in general open air climates as defined in such and such. And you see the map here taken from that standard, and you see that parts of Africa, as you would expect, are much hotter than average. And what we have in such areas is, as I said, higher daily annual irradiance, increased UV, higher temperatures, potential of sandstorms, dust, and generally longer operating time at high current, and which and at high temperature would also influence lifetime of some of the polymeric materials. And if we have a look at a recently published standard, it's called IEC 63126. The IEC Standardization Committee was trying to define what is meant by this expected average temperatures. And on the maps on the right, you can see the world map for, on the top, an open rack installation, ground mount. You see a roof parallel installation and a roof integrated or insulated PV module. And for this, you see the temperature, maximum expected temperature, 98% percentile. And you can see clearly just visually here that, of course, the insulated module runs considerably hotter. And therefore, we have to keep in mind that the standard was not written for these areas and for these installation. So therefore, this new standard 63126 is giving some guidelines. I'll come to that a little bit later. Just wanted to dive into recent past and future developments in PV module sizes. And this is the look back up to today, basically. As I said, I've been in the industry for 20 years. I can very well remember even the times before. But for a very long time, we had one standard. It was 156 by 156 cells, and also the module stayed very much the same, as I said, about 2 meter by 1 meter. But in the recent years, there were drastic, or not drastic, but repeated changes where wafer sizes became bigger, and of course also the module sizes changed. But large modules are not totally new to the industry. In the thin film technology, we also had in 2009 very, very large modules that entered the market, 2 meter 60 by 2 meter 20. That was an idea for ground mount utility size modules. It's amorphous silicon technology. Unfortunately, that technology could not meet the targets from the efficiency increase, and therefore these products have vanished from the market. But large modules have been there in the past, and that's good to know. It's not completely new to the industry. It has its pros and certainly some risks that we have to take in account also. There's a publication from the North American NREL research organization that also looks a little bit in the future cell development in efficiency, in power, and also in size. It was also mentioned in the Jinko presentation that, of course, we are now at a certain more or less standard M10 size, but other sizes are in development and is expected in the next few years to have larger wafers again. And but the total outlook here says that the module's size will not change so much, but the power and efficiency is expected to increase further. And yeah, so what is happening when I say that the standard might have insufficiencies for some use cases or some regions? First of all, we have to take into consideration we have the standards for market access, then we have some special additions. For example, bifacial module measurement and rating is something that has been rather lately this year included in the IEC standards, which wasn't there before. So make sure when you buy bifacial modules, they meet the newest standard. Then I mentioned the standard for high temperature or various temperatures, and I'll come to that in a minute. And finally, we have a recently released reliability standard. So if we look at the IEC standards, we see there's a lot of stress tests looking at electric stress, at mechanical stress, and also thermomechanical stresses. And all of these have been written more or less for a operating temperature not exceeding 70% on the higher end, 70 degrees on a higher end, which is totally fine for many places in the world. If you go beyond that, the standard suggests that the tests performed should be performed at slightly higher temperature. So you can see, for example, here it says plus 10 degrees. The temperature of the module during that test should be increased by 10 degrees, or here further right by 20 degrees. And the same is true, for example, the short circuit current. If you have, of course, more irradiance, you should also increase that current in the testing. Now, the question that we have to ask ourselves is the 70 degrees okay for a particular site I'm choosing? Or in spite of being ground mounted, do I have to go already to the next level of security? And that's a question that can only be answered by looking at the ground data and having some projects to benchmark against and so on. But certainly if it goes on building integration, which is also quite growing segment, then of course that's certainly a point to consider very deeply. If we look at the reliability, I have to come back to say the type approval and safety testing is a minimum requirement, and it's roughly a 5 to 6 month test scenario, which sorts out design errors and any issues that the modules have from the workmanship or from material inconsistencies, incompatibilities, and so on. It's all fine to do that. But if we want to know, of course, frequently we are asked, can I buy this module? Will it last 30 years in, I don't know, in Dubai? And, you know, that's a question not to answer from just, you know, I have a certificate. I have a test mark by a renowned organization. That's not all, because as I stated, first of all, the site-specific requirements, but secondly, standards evolve and also products evolve. And with any new component entering the market or any new design advance, there also becomes an unknown territory because that product hasn't been tested for a long time outdoors, and also new materials might not have a long enough track record. And therefore, the IEC committee, together with manufacturers and suppliers of raw materials, have set together over, I would say, the last 10 years, basically, to define a test protocol that goes beyond the market access barrier and trying to filter out what benchmarks these materials and avoids failures. Because, I mean, like I said, any new change brings new risks. So I remember when solar cells became much thinner about 10 years ago. First of all, we all of a sudden everybody talks about micro cracks. That didn't happen before because the cells were so thick, there was no issue with that. Then, you have the whole things about potential induced degradation, which was a big phenomenon, and it took a while until the industry could manage it. But all of these were not picked by the standard test scenarios because there were new failure modes that didn't happen before. So it's always important that with new evolvements, also new testing scenarios representing failures found in the field have to be evolved. So what we see now is, for example, some additions, I circled them in red, that you will not find in the standard certification process. First of all is the electroluminescence imaging becoming compulsory in this to also analyze what is happening. Then we have the PID test on the right. And generally we have tests in series much longer than the standard procedure prescribes. So for example, the thermal cycling test being done 3 times, and a completely new UV sequence, which is much more severe and also run 3 times than the standard qualification standard. And additionally, we have a dynamic mechanical load or cyclic load test, which simulates fluctuating load on a module, which is particularly important for large-scale modules. The bigger the module, of course, the stronger the design has to be on the frame, like it was shown on the Jinko presentation. And of course, the risk for cell breakage is higher the bigger the module becomes, and therefore this dynamic load, which also simulates wind fluctuations, is very meaningful. The standard protocol only prescribes a static load test, which is more, simulating, also wind, but not the vibration, only the static part of it, and also snow loads, which are of course relevant to some parts of the world. What again is not shown is here, for example, is the LETID, light-induced and elevated temperature degradation phenomenon, which has a separate standard. It's also very important to benchmark modules against now, because that has been a failure in recent years. Also, what we know is that in the last 3 to 5 years, we had a lot of issues with backsheets and also with cables, which would be picked by these new test requirements, but not by the original standard. Finally, topic of my presentation, sand and dust testing. Now again, there is no such standard for PV modules specifically designed for sand for modules, but we've done a lot of research in the recent years to see how can we utilize existing standards and make them meaningful for solar modules. And you differentiate between blown sand and trickling sand. For the blown sand, what we do is before and after the sand blasting, as I call it, we do angular dependence measurement of the short circuit current and see if there's any changes in the transmission of the glass or anti-reflective coating being damaged. You can see the curve here in the angle degree of the tilt of the module towards the light source before and after sand testing, and also the degradation in the short circuit current, which is directly relevant to the transmission of the glass. The other thing is, of course, if you turn the module around, the backsheet being polymeric in many cases may also have a big influence based on a sand blowing test. And then, of course, you have to check the insulation properties before and after. Second one is the sand trickling test. It's a Northern American standard, but there's also a German standard, which is quite similar. And there is a certain load of sand trickled on the surfaces, and you can see here we did this for some polymeric backsheet, and you also can do the measurement of the thickness of the backsheet before and after. And also you see here on the anti-reflective coating, which was aggressively removed on this particular module here. With that, I think I'm good on time. I conclude my presentation. So hope you take away that the type approval certification is not the only requirement you should put when you source modules. It's a minimum market entry requirement, but it doesn't say anything about how a module is compared to another one. Also, it does not include climate zone specific requirements, which would have to be looked at closely based on the use case. Reliability testing is a compromise between test duration and budget. Of course, you cannot test for 35 years to say it lasts 35 years, but at the same time, you don't have that one chamber that combines all the things like UV, wind, and snow, and everything in one test. So you have to do compromises, which also can be paid and don't last too long, and therefore keep in mind that testing is always a compromise between budget and time constraints. Components, on the other hand, are also a very important part to look at. Choose the right components to fit the specific requirements, and not only the module alone, but also the cables in the power plant, the inverters, and everything. Larger size modules, in particular, are higher prone to thermomechanical stresses. Therefore, the dynamic load test and thermal cycling tests are quite critical for those and should be taken a special consideration. Sand abrasion testing is useful to assess coatings, but also polymeric surfaces. And I think I already said the test reports and certificates do not replace project level quality control. And therefore, when sourcing for a large scale system, our advice is always to do project level power verification and some reliability testing and auditing. With that, I'm at the end of my presentation, and thank you for your attention.
Thank you, Jörg. I appreciate this very, very insightful presentation. I think it motivated many questions, and I'm happy to see on the slide here that you guys are in Intersolar. This brings back the positive feeling that Intersolar is coming again. Hopefully we'll meet face to face in Munich, and you'll be personally present there, right, Jörg?
We'll be there, yes.
So for those that are attending, if you will be in Intersolar, I think if you pass by the booth here, A5 555, you can meet with Jörg, and I'm also looking forward to meet with all of you in person. So with this, I think we've concluded the main part of this presentation of this session, and we'll move that now to the Q&A section. First of all, I want to mention something that it's very important what we have noticed now from the both of the presentations. So we've been talking about the new form factor for these new high power modules and how they are suitable for the Sub-Saharan Africa region. And in the first half of discussion today, Titus talked about how a manufacturer takes care of the quality of the product that is being produced in order to be able to fulfill all of the expected characteristics of it, and in order for it to be suitable for the market. Talking about the BOM, I'm sure that there are also a lot of innovation that happened at Jinko Solar in the production, like the new busbar technologies, and you have new connectors to replace MC4 connect. We'll get into that in a while. And then you complemented that, Jörg, with saying that having a test certification alongside the module is good. It is great, but it's not enough. So that's more of like market entry requirement or the bare minimum that we have to expect from manufacturers. But we definitely have to ask for more than that when it comes to quality. So that will be my main takeaway for the session today, and we'll complement that with the questions that we have received from the audience. So I'll start with the first one, asking EU Titus, please. So what are the challenges that you have experienced as a manufacturer, changing the regular or the classic design of PV panels? We've seen that how, for instance, you moved from the rectangular ribbons into the round ribbons, and that's something that after many, many years of doing that always in the same way. So what are the challenges that you faced, and how it contributed to produce a better and a more durable and reliable product in the end?
Yeah, thank you so much, Monique, for that question. So I would say generally is that I know the main challenge in the market currently is unavailability of long-term field data to, of course, test the technology. What we've seen is that we are launching new technologies almost every year. We are launching new technologies for the PV modules. So specifically on the multi-bus bar, you see it's something that with the unavailability of long-term data is that we've been forced to mostly focus more into our internal tests, in that we of course do our own internal tests. one thing that we mainly focus on is the reliability of the PV modules. You understand that having more bus, of course, that means that we are, of course, having more connections inside the PV modules. And of course, there's high chances that we might have more electrical losses. So that means that we were forced to, of course, focus on that and optimize, make sure that we optimize on the correct size. And that is how, and in the main challenge, I would say it was ideally coming up with the right size in terms of diameter of the round wires that we are going to use specifically for the multi-bus bus. So that was the main challenge. But at least after a series of reliability tests, that is internal tests, and also with partners like the likes of TUV, SGS, and also PVR, is that we've actually been able to get confidence that whatever we are giving the market is actually reliable, not only for short term, but also for long term.
Mm-hmm. Perfect. Now, thank you for this, Titus. Then I would like to move it now to York to answer a couple of questions that we received from Amjad Madeni. And I think his question comes from that they don't have the equipment on the site to test the temperature of the cell. And he says, if the ambient temperature is like 50 degrees Celsius, how much should they expect the temperature of the cell to be? And how important comes then the temperature coefficient of the PV module? How important comes it into play in this case?
Okay. I take that as two questions because they're both important. So first of all, we do run a test site for a couple of years in Tuval, Saudi Arabia, which we have with all these sensors, spectrum, temperature, for a long time. So we have quite a bit of experience. This is free rack mounted modules, and also benchmarked several modules there for energy yield comparison. Now, of course, with the different modules, we also used to have amorphous silicon and cadmium telluride and other modules. There are also differences in temperature, because if you have a black surface module, or you have a module with a better temperature handling, you also can reach lower temperatures than for other modules. And therefore, I can answer generally in that site, we do get, of course, 50-degree ambient, and we also reach modules temperature of 70 degrees. We had modules run hotter. So the 20 degrees is a good start. But what you have to keep in mind is, in particular, at lunchtime, maybe not in Tuval, but in other sites, you also have highest irradiance and quite often very low wind speed. That means the whole effect of cooling through wind is going away, and then you can reach temperatures that go up to 90 degrees in worst case scenario. And also that depends a little bit on the temperature household of the module. And there are designs that can cool down quicker than others. So that plays a little bit into the temperature coefficient. So the one thing is looking at the highest temperatures for suitability of the materials. But my graph before was going into what is not the absolute maximum, but the 98% maximum reach. So a regularly reached max temperature. Temperature coefficient is important as such that it is the highest influence on the energy yield. If the temperature coefficient is low, your overall energy production will be better. It's not really playing into how hot the module will run or not. It's just the efficiency of the module. And since in the Sub-Saharan Africa region you have a lot of time at high temperatures, the lower the temperature coefficient, the better your project return.
Perfect. Thank you, York, for this answer. And I think there will be a lot of learning that will come from this site that you have in Tuval in Saudi Arabia that could be applicable for the whole region, because the weather is sort of comparable for a very wide range of countries and location where solar is being built currently in Middle East and Africa. I move to the question that we got from Mr. Tabet, who asks about degradation. So I think this question I would like to direct it to both of you, please, just because to hear the answer from both perspectives. So for you, Titus, with the new high power modules, how do the figures for degradations look like? Especially, how did you deal with the LETID issue with the new modules of Tiger Pro that you produce?
Okay, Munif, I'll go first. And let's say that, of course, degradation of the PV modules is one as a result of different factors. And let me just answer by first focusing on LETAD. So as I mentioned, is that in my presentation, is that LETAD was a main concern, especially in around 2018, 2019, because of because of the introduction of the monopack modules, or rather the pack structure. So it's more of a phenomenon that is directly related to the cell structure, that is the cell structure. And as a manufacturer, what we are doing what we are focusing on is that one, we are focusing into the manufacturing process. Then we're also focusing into that is the quality of the wafers that we're actually using. And it also comes into the thickness of the wafers as well. So in summary is that for LETAD, what we've been mainly focusing on is one, rigorous testing. Then on the thickness of the wafer is that we've tried to make it as thin as possible. Then we've also tried to improve the quality by one, that is in reducing the hydrogen content inside the solar wafers. And yeah, so and just recalling is that sometime in 2019 is that we were actually the first manufacturer to incorporate LETAD testing in our production lines. And also we also were among the first manufacturers to be awarded an LETAD certificate by TUV. So it's more of rigorous testing and also improving on the quality of the wafers. Then the other thing is, of course, degradation also can be as a result of temperature. That is, as Jorgen mentioned in the presentation. And we've tried as much as possible to improve on the degradation in that on the temperature coefficient. In that currently our P-type modules, the temperature degradation is minus 0.35% per degree Celsius. Per degree Celsius, and for the N-type modules, I said is that the more of the next technology that is going to take shape in the market is minus 0.3%, minus 0.3% per degree Celsius. So those are some of the key improvements that we are working on. So I'd like to maybe just a brief summary of to your question, answer to your question.
Perfect, thank you. And I would like then to direct this now to you, please, Jörg. Like, how would you help investors and EPCs and developers in order to make sure to have a proper estimate of the energy yield and to expect the degradation of their projects?
Yeah. I mean, it's a complex question, but of course, first thing is you do your energy yield prediction correctly for the site, and for that you need good data, not just relying on satellite data, but as good data input, the better the output. And for this is also important to use not just a data sheet entries for the simulation in simulation softwares, but actually use proper PAN files, which have been generated best by a third party, independent data. And for this, you can find what is the best match for your location. As for degradation effects, of course, I was trying to highlight it before, there are certain minimum recommendations I would make for what sort of testing should be done in a large-scale project, because you wouldn't do it for a one household 4 kilowatt project. But of course, if you're building several hundred megawatt or 100 megawatt, then sourcing the modules and taking requirements to your suppliers that you will have somebody go in and check on certain things and maybe take some samples on random, that will automatically lead to the result that the supplier will bring you most likely better modules, because if they know somebody's going to check and do some tests randomly, they are most likely going to be not taking any shortcuts. Which is also, I think, one of the questions I see further down. What can you do to avoid low quality and low certified products to come to the market? I think that's a learning curve that many countries had to go through the hard way, and it's an investment. It's a 25-year investment, but sometimes the developers or the EPCs are only in there for the first 2 years, and they hope it will go good, and then I'm out, no problem. But unfortunately, a lot of these projects fail miserably, and the banks will not give loans for it anymore. So I think the lever is with the investors and the banks who have a long-term interest to avoid such radical failure, because that's also not good for the industry if we have such failures, because then the next project investment will be harder to manage.
Perfect. Thank you for this, York. I think we crossed the time, but still I would like to get to two very short questions, please, if we can get two quick answers for them in order to answer the majority of the questions here. I have a question from Abdenoor Sofi from Somalia. And he says that in Somalia, the market is flooded with a lot of low quality, cheap modules because of the price wars among the vendors in there. And he asks, okay, what are the main, let's say, changes that a market could adapt, to filter out all of these low quality modules to make sure that what is present in the market is actually of at least the minimum quality that is required for a solar project. So that's more of like comes probably to the regulations perspective, for like to put rules to import certain solar modules. But for the current, let's say for the meantime, how do you see this, Titus, from your side, okay, as initial low-hanging fruits, easy steps in order to kind of make sure that the products that are in the market are of better quality and being imported to the market?
Yeah, Monif, I would say that the question of quality is more of, it's actually something that is very important. And even with the regulations, especially in most governments or rather in most countries, is that they might not actually be able to handle the issue of low quality modules. And I would like to maybe make a comment from a project development perspective in that the investors and the project developments, they need to invest more into, of course, qualified consultants to be able to get the right advice and also do some very good background checks on which technology they're investing in. Because remember, they're investing, it's huge investment that they want to maybe recoup the investment and also make profits in let's say 3 or 4 years. So that means that investing in low quality will lead to not only reduce the reduced generation that is from the PV plant, but also that is failed installations. And again, is that this also needs to focus more into not only into the initial installation costs or rather the capex. There's need to focus more into the levelized cost of energy or rather the long-term performance of or rather generation from the system. So it's important to simulate that is ideally for let's say 20 to 25 years or 30 years, depending on the lifetime of the project, than to focus more on the initial capex.
Okay, perfect. Thank you for that, Titus, for the answer. And then I will direct the last question for you, please, York. It comes from Sharif Amir. And he says with the new high power modules, they are bigger, they are heavier. Of course, there are some installation challenges in there. So I believe you also at TÜV, you support also this installation phase for EPCs. And maybe like we want to know from your opinion, what are the biggest considerations, most important considerations, or the biggest challenges for installing the high power modules?
Yeah, I think there have been other webinars where also there was an outcry from some of the EPCs because, and in particular also the tracker manufacturers, because the larger modules required redesigning trackers, required redesigning mounting structures, and of course reconsidering O&M practices. But I think that's more or less in place now. But of course, if you're new, what you have to consider, of course, a lot of these large modules are now bifacial as well. Tracker load is going to be higher, and also you have to make sure that the backside shading is minimized. So how to install the modules is quite important, and it's not just you can change one module against another. It needs to be designed properly so you can minimize backside shading, and also take into consideration that there is no shading from the tracker itself. As for weight, of course, I mean, if you're ground mounted large scale, it's not such a big issue. If you want to take this on industrial rooftop or where size matters and there's not much room to move, it can be a considerable pain to the installers.
Okay, perfect. Thank you, York, for this input. And I really wish to thank both of you, Titus and York, for this very informative presentation that you have prepared for us. the questions that you answered through this Q&A session. I think we answered most of the questions that were there in the Q&A box. And I'd like to invite everyone to follow, again, the Jinko Solar's Sub-Saharan Africa Facebook page for similar events in the future. I'd like to thank all of the people that attended here on Zoom and live on social media, and looking forward to see you in future webinars in collaboration with Jinko Solar and TÜV Rheinland and other industry leaders. So for now, I wish you all a sunny day, stay healthy and safe, until see you next time. Thank you, Jörg. Thank you, Titus.
Okay. Bye.
Thank you.
Bye.